Dear friends, once again in VK Jain Sir ki MEP classes. In this particular series, we have discussed many aspects of firefighting. One of them is smoke control system. Smoke is very disastrous to human being. If inclined by smoke, the particular person may die. That's why it is very important to control the smoke in a particular building. Now, if there is a established fire, uh, there is a tendency for people to take up the staircase or lift and go down. That is vertical transportation system. Second is basement. In basement, when number of car or parks, there is a tendency for smoke to get generated. It may be uh, carbon monoxide or carbon dioxide. Both are dangerous to human health. That's why we need to control the horizontal basement ventilation when basement is used as a car park. We have discussed the requirement of smoke control as per international standard NFPA of USA, but now we are going to discuss smoke control systems as per National Building Code 2016. These systems are designed to limit smoke spread, maintain tenable conditions, and add evacuation and firefighting procedure. Now we'll discuss the type of smoke control system. The first one as per National Building Code 2016 is smoke venting system. Remove that is removing smoke from a fire zone by mechanical or natural vents. This is used in factories, atriums, warehouses and auditoriums. Second, smoke containment system, that is preventing smoke movement from one zone to another. This is achieved by A. Fire rated doors, B. Fire smoke dampers, C. Pressure differentials, E. Sealing of shaft and penetrations. Friends, we are discussing smoke control system as per National Building Code 2016. We have already covered two items. The third method is of pressurization system. Staircase, lift, refuge area, pressurization. This is vertically applied. In this system, we are maintaining higher pressure inside protected vertical space, roofs to smoke so that smoke cannot enter. This is used for staircases, B. Lift shaft, fireman lift for lobbies, fifth refuge area. Now the fourth method of smoke control to smoke is applied to smoke exhaust or extraction systems by mechanical fans that extract smoke from corridors, basement, tunnels, underground car park, often paired with makeup air system also. The fifth item of smoke control is smoke dilution systems introduce outside air to dilute smoke concentration used in large open areas where complete extraction is not possible. Friends, the sixth item for smoke control is of zone smoke control systems. In this building divided into smoke zones, only fire affected zone effect activates extraction, other maintain pressure to avoid spread. This system is used in malls, airports, high-rise buildings. Seventh item is regarding tunnel and metro smoke control systems. This includes basement smoke purge systems, second car park and jet fan system, and third kitchen smoke extraction system. To summarize, dear friends, the objective of a smoke control system. The objective of any smoke control system is to keep the smoke and toxic gases out of the escape route long enough to allow the occupants to escape or seek a safe refuge. In addition, an adequate smoke control system will help the firefighters deal with both fire and any residual smoke. Second category is of smoke ventilation. In large open space buildings like car parks, shopping centers, and exhibition halls, etc., the usual method of smoke control is by ventilation. And this ventilation for extracting the smoke from the area. Friends, in high-rise multi-room buildings where the staircase, lift lobbies and corridors provide the escape route, smoke extraction may serve to worsen the situation. So is a smoke extraction system illustrated in figure shown next slide will provide negative pressure in the escape routes which will tend to draw the smoke into very space requiring protection. Friends, this figure explains the vertical smoke movement by maintaining negative pressure in upper floors. The second method is of pressurization. However, it is possible to hold back smoke from a fire by simply supplying clean air into escape routes, thereby developing excess or positive pressure in the spaces requiring protection. In the figure 2 to be shown in next slide illustrates the method which is known as pressurization. In a pressurization system, the air must always be away from the escape route to ensure that there will be a higher pressure than surrounding area. Friends, first look at the figures given on right hand side of this slide. This explains spaces to be pressurized. There are two methods. One is staircase only, as shown in figure 11. In this, only the staircase is pressurized. The smoke control system will provide protection to the vertical part of the spake route only. It should only be used when a staircase is entered direct from accommodation or via a simple lobby, that is, a lobby without lifts, toilet, and other possible air escape routes here. Second, staircase and lobby. The figure 12 on right hand side explains this. Two duct system from a common fan required both for staircase and lift lobby used where lobby provides outlets from lift, contains toilets or other ancillary rooms. In this diagram, you can see a lift lobby and then provided in a enclosed space. Then second one is staircase and third one is the accommodation of the building. Friends, the third method of smoke control is vertical smoke control use is using staircase, lobby and corridor. Extending the lobby pressurization system into corridor using additional outlets in the corridor. Now, this is explained like this. The lift lobby is enclosed and separated by staircase lobby, and these two combined uh, are separated from corridor, and the corridor are provided smoke outlet systems. So the smoke, the fresh air comes through the lift and lift lobby and the staircase lobby and escapes through uh, this vertical ventilation escapes through corridor through several or one outlet provided permanently that opens in case of fire. The fourth system is of lift shaft. That means through lift shaft, this is lift shaft, and vertical air comes here, and through lift it goes into staircases. Friends, through this slide, I have tried to summarize some of the terms used in smoke management. The term smoke management is an all-inclusive term that covers physical features, equipment, and methods used separate, separately or in combination to control the movement of smoke. The three features are the physical features are the passive elements such as smoke's resistive construction. Second one is equipment includes items such as fans, operable windows, and smoke detectors. Third, the method or design schemes such as compartmentation, smoke venting, and smoke control. By compartmentation is a process in which physical features designed to control smoke movement by passively controlling it within the smoke source area by dividing the rooms. Smoke venting. Smoke venting uses non-ducted standalone equipment, that is a smoke vent in the building envelopes designed to control smoke movement by releasing it under its own pressure to the outside. Third, smoke control uses equipment, that is fans, ductwork, dampers, smoke detector, etc., designed to control smoke movement by actively and mechanically creating pressure differentials. Smoke control systems are usually dependent on physical features of the work properly. We have to see a table and calculate uh, the quantity of mechanical extraction and area wise if ducting is provided. The rules for mechanical extract state that for control of fumes, a system which is capable of limiting the concentration of CO within the car park to below 30 parts per million averaged over an 8-hour period taken. For smoke clearance, 10 air changes per hour should be extracted. The formula is floor area multiplied by height is equal to volume. Air changes per hour. The number of times the volume within the car park is extracted within 1 hour. The regulations for smoke clearance state that the system should have an extract facility which is split into parts, each part capable of providing 50% of the required duty and extracting from both and high and low level. Extract fans should be rated at 3000 degrees Celsius for 1 hour. Friends, this chart provides air change per hour required for certain areas which are affected by smoke, deep smoke. And the part 1 or column 1 of this illustrates types of the building. Second column illustrates source of information. And third part gives us required air change per hour for smoke control. Playroom, it is 10 to 20. Public toilet to be designed with 4 to 8 air change, this one. Banks required for 8 to 10. Libraries require 8 to 12. Assembly hall require 8 to 12. And laboratories require 8 to 12. These are the common practice in area where there is no air conditioning. Similarly, these all information is from CP 352 1952. The other portion of this includes canteen, factories, cinemas, kitchen, photographic darkroom, boiler houses and foundries. This is given 10 to 20 for canteens, 20 to 30 factories, cinema halls 12 to 30, kitchen, restaurants 20 to 30 air change per hour, photographic darkroom 20 to 30, boiler houses 40 to 60, foundries 40 to 60. Friends, this chart is for calculation of number of fans and their diameter required for smoke control in horizontal ventilation against a certain pressure. The uh, Through this chart, we can calculate the CMH cubic meter per hour required for a particular fan against a particular pressure through this chart. The chart shows first column the diameter of the fan in millimeter, and second shows the kilowatt required for moving that fan. The third shows the RPM, and fourth shows the cubic meter, rated cubic meter. And this rated cubic meter is against a certain pressure. If the pressure is given, then you can see all these columns and calculate CMH against that particular column. Say if it is 25 mm, you have to see the pressure differential and select a fan. This goes from 10 mm to 40 mm. So the pressure against which the smoke ventilation is required is given in all these columns, or the rated capacity of that fan is given in this. You can take this in case the pressure differential is not known. So let us take one example. Suppose we selected 305 millimeter diameter impeller diameter, then it will consume 0.37 kilowatt only at 2850 RPM. Normally fans are required in different RPM ratings and they are available. Say some particular fan may be available in several diameter ratings. Say take case of 610 mm, it is available in 1420 RPM, 1420 and 2850 RPM and 950 RPM also. So these are the required CMH ratings. Friends, this chart shows the fans of different type used in ventilation purpose. Normal ventilation or maybe for smoke ventilation. The easiest is the table fan, which we quite often use in for greater purposes, for ventilation purpose only, not a smoke control. We may use man cooler or air circulating fan for higher circulation, air circulation. The third one is known as ceiling fan, which we use in our rooms for air circulation only. Now, these three types are used for smoke control. The simplest of these three is radial impeller type, uh, which is known as centrifugal exhaust fan. A centrifugal exhaust fan of a smaller rating used in toilets, and for bigger it is used in smoke ventilation for other area, say in vertical formation or horizontal formation. The third category is known as axial flow fan. Now difference between axial flow or radial flow, these two are radial flow, Radial flow are also known as centrifugal exhaust fan. In radial flow impeller, the media, that is air, is uh, enters axially and leaves radially. That is why it is called radial or centrifugal. In the other type of impeller, which is this one, air enters axially and leaves axially, and this is the mixed category. Friends, we have seen two different type of fans used in smoke ventilation of car parking systems in the basements. The axial flow is also called propeller fan. There are three basic type of axial fan: propeller, tube axial, and van axial. Propeller fans are most commonly used for diluting ventilation or for cooling purpose. These fans are often mounted in a wall or ceiling. Common examples are your automobile radiator fan or a freestanding room fans. The basic characteristic of these fans include that they can move large amount of air if there is a little resistance. Second, they are suited for local exhaust ventilation because they don't provide enough suction to draw air through the system. Third, tube axial or van axial fans are essentially propeller fans made to fit in a duct. They are also usually limited to clean air applications such as exhaust duct going through the roof. This chart provides the air displacement in cubic meter per hour of different type of fans, which are known as exhaust fans or ceiling fan. Exhaust fans are available in RPM category of 1250 and 1400, two different speed, and the lower RPM fans are known as domestic, and the 1400 are known as heavy duty. The domestic category fan, exhaust fan, uses 40 and 45 watt, and otherwise they can be 80 to 240. This one. The next one, so just for comparison purpose, a ceiling fan. A ceiling fan of 1200 mm circulation sweep. This is known as sweep. That means it will have a diameter of 1200 mm circular diameter, and it uses only 50 watt if it is selected properly for energy consumption, and its CMM capacity is very much limited, which is 225. So approximately one one third of the 40 watt domestic exhaust fan.